So here we have the 2014 question 6 leading cert higher level question on sequence and series. We're told that the nth term of a sequence Tn is the natural log of a to the power of a to the power of n, or ln a to the power of n, where a is greater than 0 and a is a constant. Show term 1, term 2 and term 3 and are an arithmetic sequence. So the knowledge required for arithmetic sequence is we have a common difference. So let's see. So if there's a common difference, it means that t2 take away t1 would have to be equal to t3 take away t2. So fill some values in here. Term 1 and term 2. First of all, term 2, let's write them all out separately. Term 2 is equal to natural log of a to the power of 2. And we know from our rules of logs that's twice the natural log of a. Term 1 is equal to the natural log of a to the power of 1, which is just the natural log of a. And term 3 is equal to the natural log of a to the power of 3, which is 3 times the natural log of a. So fill these into our equation that we've created to show it's true. Term 2, 2 ln a minus ln a. Is that equal to 3 ln a, which is term 3, minus term 2, which is 2 ln a. So 2 minus 1 is just ln a, and 3 minus 2 is also just ln a. So QED. So to prove this sequence is arithmetic, what we need to do is use Tn and Tn minus 1. We could also use Tn minus 1 and Tn minus 2. Let's use both. So term 2 take away term 1 will be Tn minus 1, or term 5 minus term 4. So Tn we know is the natural log of a to the power of n. And then what is Tn minus 1? It's the natural log of a to the power of n minus 1. So this becomes n times the natural log of a minus n minus 1 by the natural log of a, which is, if we multiply this out, n ln a minus n times ln a, and then we minus 1 plus ln a. So these cancel and we're just left with ln a. Now that's probably enough. That's all they're looking for. But let's just show that term n minus 1, so let's say term 5 minus term 4 is equal to the same thing. And then we've just doubled up in our proof. So the natural log of a to the power of n minus 1 minus the natural log of a to the power of n minus 2, which is n minus 1 by the natural log of a minus n minus 2 by the natural log of a. Multiplying these out, we get n ln a minus ln a minus n ln a plus 2 ln a. This will give us the first difference, I think. Are they looking to find a common difference? So this will give us the common difference as well. So the n ln a's cancel, and we're left with 2 minus 1, which is just ln a. So it's proved, and we found the common difference is ln a. So in part B, we're asked to find the value for a for which t1 plus t2 all the way to t100 is equal to 10,100. So we fill in what these are. ln a plus ln a to the power of 2, so that's 2 ln a plus 3 ln a and so on, all the way up to plus 100 ln a is equal to 10,100. Now we could use a formula n over 2 to sequence we're adding together, plus twice the first term plus n minus 1 times d. I like the d in front though. Or we could say, well, it's like the numbers on a dice. 1, 2, 3, 4, 5, 6. 1 and 6 is 7, so is 2 and 5, and so is 3 and 4. So you add the first and the last and triple them to get 21, 3 7s. So in this case we could add the first and the last and multiply by, there's 50 pairs of numbers here, so ln a plus 100 ln a is equal to 101 ln a, multiply by 50 pairs of them, and 100, that's 5050 ln a would have to, ln a, don't forget your a, is equal to 1100. So dividing up divides in evenly, doesn't it? So that's ln A is equal to 2. So that would give, knowing our rules of natural logs, that would mean that A would have to be equal to e to the power of 2, or e squared, and I calculator e to the power of 2, 7 point something, 7.389. Okay, part C. We're asked to verify that for all values of A, term 1 up to term 10 added together plus 100 times the difference, which we know is ln A, is equal to term 11 all the way up to term 20 added together. Okay, well, let's do this the same way. With 10 numbers, we have 5 pairs. So we have term 1 plus term 10 multiplied by 5 plus 100 ln A. What's term 1? It was ln A, the first term, and term 10 is 10 ln A. That's going to give me 11 ln A times 5, which is 55 ln A. Good maths to keep writing what we have so we don't forget it. So we have 155 ln A. So that must be what the right hand side is. Let's have a look. Again, we may as well do it the easy way. I think term 11 plus term 20 times 5. So 11 ln A plus 20 ln A. What's that going to give me? 31. 31 ln A by 5. That's 31 there, which is 155 ln A, which is equal to the left hand side, QE.